Thank you very much. So I want to actually start off with what Mo and Samuel talked about in the previous talk, and especially this idea of server-driven UI. And there's one aspect of that that I find particularly interesting, and it's actually not the same that Mo really liked. I really like the aspect that by having this combination of your logic or your app and the config module, you're sort of empowering a lot of people that are not necessarily developers to actually participate in building your application. And like the live version, right? Not just feeding into developers, but literally on their own can go and make changes. And I think that's a very interesting concept and something we're exploring a lot at Toddle. So maybe a short introduction. My name is Andreas. I'm the founder of a company named Toddle, which is a technology I want to talk about today. But before we get there, I want to talk a little bit about the future of the web. So about, what is it now, a little bit over 10 years ago, we really saw a fundamental shift in how we build web applications. We went from using tools like jQuery, MooTools, whatever we used before, to using these modern frameworks that came out. And it really did change everything, not just how we build applications, but also the kind of things that we could build, right? And we've seen this monumental shift. Now, over the last 10 years, these frameworks have gotten better and better and better. And to the point where they're beginning to converge a little bit on a core set of ideas that are really, really powerful. So I don't know what the next big thing after React is going to be. Maybe it's quick, maybe it's solid. But I think I can make pretty educated decision that it's going to be component-centric architecture. It's going to have a combination of server and client rendering. It's probably going to have signals, and it will likely also have some sort of compiler. And so we haven't seen this kind of monumental shift that happened back then. We haven't really seen that yet. And actually, we're beginning to see a conversion of technologies. And I think when we look at what is the next big shift going to be, it might be less about what are the tools we're going to be using to build, or technologies we'll be using to build these things, and actually a little bit more about who are building them. And this is not an AI talk, just to be clear. And I think the question of having product managers be able to configure these things themselves without needing to rely on a developer is a good place to start. But I want to take that much, much further. So what if everybody on your whole team could actually directly contribute to your product and help build your application? Now, I'm not saying everybody is an engineer and everybody does everything, because obviously there's a lot of hard problems that you need engineers for. But there's also a lot of problems that you probably shouldn't need an engineer for. So why can't designers implement their own designs? Why do they need to hand us off Figma files and then we get it wrong and they come back and say, actually, that doesn't look anything like what the designer did. Can you please do it again, right? Why does marketers and product managers have to constantly ping us about changing labels on buttons, right? We shouldn't need an engineer to gatekeep the text on a button, right? Like that seems to be a simple thing that should be simple. The problem here is, of course, that I don't think the future is to rekindle the debate of whether designers should code. I mean, that's almost certainly also going to happen in the future, but I don't think that's the solution. So this leads to what I think is a more interesting question, which is the one that I've been working with for the last around 5 years now, which is when did we actually decide that a text editor is the best tool for creating visual applications? And I think for a lot of people, this idea of challenging code or text as the way we build application is quite foreign, because for a lot of people, it's basically challenging what programming languages are. But I think if we look at what a programming language is, actually, I'm fortunate I don't need to explain what an AST now is, because that actually already happened in previous talks. But in short, it's an in-memory representation of your program in that language. So what a compiler actually does, it takes your source code, which is what you write, it creates this AST representation and then does a bunch of stuff, optimizations, etc., and then spits out this binary code that runs. So when we look at what a programming language is, we often look only at the source code part. But in reality, the source code is the interface for a programming language, and the whole thing is your programming language. So what I'm suggesting here is, what if we did this? What if we cut off the interface and just replaced it with something else? And in this case, a UI tool, a GUI tool, that works directly with the AST of that bespoke language. And I realize I'm standing here presenting it like I had a big epiphany and invented all this. Obviously, this is not a new idea at all. The first example that I'm aware of is now, this year, 60 years old. In 1964, at MIT, they developed this RAND tablet where you could draw on a board, and you could create these sort of visual flowcharts. And it even had character recognition like 60 years ago. And this would execute, right? You could build programs this way and actually have them execute. It cost $18,000, so it never really made it mainstream. And that was in 1964 money, right? A more recent example is Visual Basic, which some of you might be old enough to work with. And here is a demo. Unfortunately, it's from the 90s, the resolution is terrible. But this is a demo by Bill Gates presenting this as part of shipping with Windows. But the thing is, we never really made it to mainstream adoption. Like, this idea became popular, but it never really fundamentally changed how we build applications. Like, code still is the dominant and really only way we build apps today. And if we have to look at why that is, I think my hypothesis is that there are three reasons why text and why code is still the dominant idea. And the first thing is flexibility. For a lot of these tools that have been built, they essentially work by limiting quite heavily what you can do. So they make it a lot more easy. They create these very high levels of abstraction. But as a result, you're also very held back in what you can actually do, right? And I think if you're picking a platform, you're going to pick the one that isn't eventually going to come and say, you can't build that feature. You'll have to start over, right? So we need the same level of flexibility in what we can build that you have in code. The other thing is collaboration. This is a big one. In code, we obviously use Git or whatever we used before that. And if you can't work together as a team, like, it doesn't matter how good a tool is if it's a single-player tool, right? It's never going to scale. It's never going to actually solve the kind of problems we need. The first one, and I think this is especially relevant for the early days, is speed. Like, it both needs to be obviously fast to build in it, but also more important, the end result has to be performant. It has to be able to perform comparatively to something written in code. And in 1964, where hardware was very constrained, this was a huge problem, right? We didn't have the kind of optimizing compilers that could handle that kind of thing. And as a result, it was always a little bit of a second-hand citizen. And so these are not easy problems, but they are definitely solvable problems. A lot of them has already been solved for different kinds of technology. So I would like to show you what we've been working on at Toddle, and our take on how this could work, specifically for web applications. And we're loading. Right, excellent. So let me just see. Here we go. So this is the Toddle editor. So this is a visual programming language that has an editor. You configure, you basically build everything in. I say it has an editor. It technically has 3 different editors because there are different aspects of programming that it tries to solve. What you're looking at now is the visual editor. If you use something like Framer or Webflow before, this probably looks very familiar because both of those tools essentially solve that problem really, really well. The biggest difference, I think you'll notice, is on the left side here, you'll see everything we're showing here is just HTML. Toddle is not about creating high-level complex abstractions on top of the basic platform. The web platform works really well. So this is mostly just an interface. And what you're seeing on the left here is going to be the output that the application is going to have. Like, that is the HTML it'll render in the browser, right? On the right, you'll see our styling panel where we can go and change the style. And I wanted a little thing. This is actually not a particular relevant point, but I thought it was quite funny since the previous guys mentioned durable objects and how easy it is to sync server state. So since we're also running on Cloudflare, actually going and changing something like the color of the title here kind of just works and syncs across the network again, because these durable objects really does almost work like magic, right? That's not really an important part of my talk. I just thought it was really interesting that they mentioned that as something we rely really heavily on, right? So let's take a look at how this application works. I've obviously built a little bit ahead of time because I don't want to spend the whole time dragging images around. So what we have here is a very simple news app that fetches some news articles from a public available API, something called news data. And we can see here I have my API panel where I can specify all the information I want to send, like basically construct my HTTP request. And here on the right, it's returning this information. Toddle is passing the JSON data so you can go through and see what's coming back, right? On my page, I can then go and take, for example, this list item here that represents our article. And I can go and say, well, I want this particular element to be repeated so that for every single news article, I want you to create another copy of this, right? And this sort of shows the second editor in Toddle. So we had the first one, which is the visual, like the UI layout editor. And the second one here is what we call the formula editor. We kind of split up functionality, like programming into basically two concepts. Everything that's, if you're a functional programmer, this is what we call pure functions. Like this transforms data. I have an API that returns like a response, and I can sort of drill down into this and get my results out, and out on the other hand gets the final value. And I can also go and add more complex options here. I can say filter, and then say maybe I want to filter so only the items that actually have an image attached to it are included in this list, right? And so the formula actually lets you do very complex calculations, but in this relatively simple visual style. Now to show the other part, the final part of the editor, which is our workflow editor, I want to add a functionality to this app. So I'm just going to press the play button here, and we go into our interactive mode. And I've got this little search field here, but nothing happens when I type in it, right? So I want to add search functionality. So as I'm typing, it's going to dynamically update these results. Now, if I was to do that, let's say in React, the basic strategy here would be, well, I'm going to create some state. Then I'm going to grab an input field. I'm going to bind that to that state by saying the value and, well, in React state change in everywhere else input events, and then use that value in that state to fetch the data, right? And Toddle works exactly the same. Like, as you say, there's been a conversion of framework. There's a lot of really good ideas. There's no reason to change any of those, right? So Toddle works on all the same principles. We did call it variables instead of state, but we can create here one we called search string. And I'm going to start with a default value that's empty. And then when I choose my input, I can go into attributes, and then under my value attribute over here, I have yet another one of these little FX buttons are sort of indicating you can use a formula. They're spread out all over Toddle because almost anything can be dynamic. And here I can sort of map that to the search string. And then I can do the same with events. So this is as I'm doing my input. Now we did go against React here. This is called an input event as you're typing. So we did choose to stick with that. And then I can set, I want to set the search string. And this here is what you're seeing in the workflow editor. And this is basically a flowchart, not entirely unlike what the guy was drawing in 1964. You can add conditionals, etc. But essentially everything that has a side effect. Anytime you're going set a variable, call an API, update the title, any of those things, those are actions inside your workflow, as we call it here. Anytime you're just transforming data, these are formulas. And so here I can again use the formula to actually decide what data do I want to feed into my set search string. And again, I'm taking my target and value from this event, right? So everything here is like exactly the same way you would do it in React or quite a lot of other frameworks, just done with a visual interface, right? The last thing I need to do is, of course, inform my API that it needs to now actually search through this. So I'm going to open up this API right here. And our API interface here is very inspired by React Query, has a lot of the same ideas. So we call it auto-fetch, and it basically means it's automatically going to fetch the data when required. So if I'm going down in here to the query part of my interface, where right now it's marked with a Q, obviously it's dictated from the API. If I change this from the hard-coded value of AI to actually be a mapping to a search string, now if I'm going into search, and let's say we're searching for front-end, as I'm searching, this automatically get updated. And so Toddle works based on signals, like a lot of the new frameworks. So as I'm changing the variable, it realizes that the API needs to change. The API then goes, well, my data has been invalidated because they changed the search query. I need to now go and refetch that, right? One little thing we could quickly do before we start testing too much is add a little bit of a debounce value of 300 milliseconds. So we're not hammering the API necessarily on every single keystroke, but just actually updating at a reasonable interval. Now that I've done that, I'm ready to go and publish this application. And so Toddle, like most things today, works on a Git-like version control. It's not exactly Git, because our underlying AST model doesn't really fit too well with Git. But it's using all the same principles. So I was working in a branch. You can have infinite amount of branches, and obviously multiple developers can work on their own things. Everything here works just like you're normally working with code in a version control system, right? And I can add a little message, added search, and I can go and publish my changes. And that will actually push them onto the main branch where they're live. And so now we can go here and say, I want to view my live app. And I can go into search and search for AI. And it's going to go and find news articles related to AI, right? So this is a relatively simple use case, obviously, a news site. But you can build a lot more complex things with Toddle. I think where a lot of visual programming languages tend to be aimed either specifically for children, or a lot of times for either beginners or people who never really intend to have a career in programming, we really designed Toddle to be for professional product teams first. So one of the other things we've built here is, oh, that's more, there we go. So we built this color picker, and this sort of showcased that you can build really interactive applications in something like Toddle with a lot of fine-grained interaction and control, again, without the need to go and write code to do that. And this color picker is actually a package. So if you have a Toddle project, you can go and install that into your project, and now you can use this color picker component. And of course, the community can build and are building a lot of these packages that sort of lets you, that you can share with everyone around you and basically build more complex things, right? The last project I'd like to show you is currently the biggest project in Toddle. This is, wait for it. There we are. And so this is Toddle itself. So everything you've seen today, the whole Toddle editor and everything, is an application built in Toddle. So right now you're looking at the main editor window here, running inside the main editor window. Yes, this does occasionally get really confusing when you're working on it. So we can see here, for example, our element panel here is the one we have here on the right. And I can double click into that and see all the different components that makes up this panel, right? So building something very large and complex means breaking up into 1,000 small components that you then combine again. And again, everything here, we didn't reinvent everything, right? Modern frameworks already taught us how to do this. You're going to have a lot of components. They're going to communicate each other through props and events or callbacks, depending on the specific framework. And again, Toddle uses all those same ideas. Even our formula editor that we used previous to build these things, this is also entirely built in Toddle, right? We're a relatively small company still. We only launched last year. But we're working full-time every day in this product, right? And one of the really beautiful things we've seen happening is that not only are engineers faster at building in Toddle than in traditional code, which gives us a little bit of a speed boost, but the fact that our designers can go in the same tool and implement their own design, the fact that our marketer can go and actually build a lot of our onboarding flow, and change not just the copy, but it's actually diving into how to make a lot of these changes directly. Means that we sort of remove this engineering bottleneck where everything that always had to happen had to be, can you go and do this, right? We don't have Jira ticket wars anymore, because a lot of the time, whatever it is you need done, you actually have the opportunity to go and do. So that was my presentation of Toddle. I hope you liked it. And you can go and try it today. It's free to try at toddle.dev. So if you're curious to play around with this and see what this kind of development could look like, please do that. And please let me know what you think.
Thank you very much. That was the sickest dog fooding demo I've ever seen. I was sort of thinking about it when you were demoing. I was like, is it possible that he's going to show that this whole thing is built in Toddle? I don't know. I just got the vibe. Very well done. Very well played.